You look super cute.
But I need to stop hugging.
Very nice.
I need to stop hugging the building.
Stop hugging the building.
Okay. We humans, we want to build, we want to construct. That's cool. Also not so cool, because building and construction is one of the highest emitters of greenhouse gases in the world. That's why we did this YouTube channel called Reconstructing the World. My name is Anders Morgenthaler, and right now I'm going to take you through building process Reconstructed with Anders Linnager, one of the most sustainable architecture in the world. This is Anders Linnager, the most sustainable architect in the world. He built this, also this one, and also this one. Actually, he built tons of stuff. Always trying to upcycle old materials to new ones. Because Anders believed that using waste to resources is the only way to reconstructing the world. And for the next year, we're gonna follow the construction of this baby. One material at a time that Anders and his team came up with. It's gonna be super exciting.
As Anders mentioned, this baby is a building that we're building right now. It's probably one of the most sustainable buildings in the world right now because we are only building this out of materials that are known as being super sustainable. Even some materials that doesn't even exist. So let me just explain to you guys what this actually is. It's an 80-meter high wood building, and normally in Denmark you're allowed to build 3 stories. That's down here. And we are building all the way up here with massive floors, slabs in wood, and columns also in wood. Then we have upcycled concrete and FutureCem. It's a new type of concrete in it as well, only for the cores, minimum use of concrete. But all the other materials then are upcycled materials made out of waste, converted to new products. And that's the interesting part here, that we're pushing this building to the limit of what's possible to do today, and thereby actually creating a high-rise office building that points in the direction of what we are going to see in the future if we want to lower the CO2 with up to 70% or maybe more.
No, we're gonna fuck that TikTok jumping. From now on, no more TikTok jumping thing at all.
No jump.
No jump. Okay, so today, Anders,
yes,
most sustainable architect in the world, Anders Linnager. We're going to talk one of the biggest issues today,
yes.
right? What is that?
The biggest issue and biggest problem for the building sector is the structure, the load-bearing structure, because that's where we use so much material and that we have the biggest difficulty in finding solutions, because it is difficult to build a sustainable, especially high-rise.
Load-bearing, is that
load-bearing, so all the weight, all the kind of strength that needs to be handled by the building's core, which is beams, slabs, everything that's creating the spaces for the building. So that's what we're going to talk about today. And what's unique about træ, which means wood, or
let me guess,
a tree in...
The unique thing is it's built of wood.
You got
super
it, Anders.
Super unique.
Anders here understand it after one program. That's super quick. So we call it a hybrid structure, but let me first talk about where the wood is, or the tree is kind of manifested. So all the beams that you see here, they are 50 by 50 centimeters. We're going to show you that up close in a minute. That's massive wood. So it's carrying the loads from the facade or all the way into the core of the building. Then every slab of these 20 stories that are on top of each other is also massive wood. And it's called CLT, so it's cross-laminated tree. So that's kind of the main topic for this chapter today. So we're going to dive in, why is that sustainable, and how did we do it?
We somehow didn't agree on the naming, so you call it chapter, I call it YouTube episode, which is also wrong.
The chapter episode.
Today's episode. I feel that's the.
It's because I'm leading here, so it's more important. So it's more chapter.
Today you're leading.
It's kind of like a book.
Okay. So Anders, why we are discussing this at all is that 40% of all
CO2
emissions in the world comes from constructing building and maintaining buildings, right?
Yes,
So
exactly.
it's actually
but you're so right.
so right.
But what's really interesting for us today is that out of the 100% energy or CO2 usage for a building, between 40 and 50% of that is the main construction, the structure of the building. And that's why we really have to look into the most difficult parts and how we can save CO2 by building differently. And so instead of concrete, steel, we want to use wood as we do in this building. And we also have a core in concrete, and that's why this building is called a hybrid building, because we've optimized where it makes the most sense to use materials.
But the core of concrete is a tiny one hidden inside, like where the
elevators and escape stairs.
Escalators, all that. Okay, so that's inside all that, right?
It's in the center of the building, so it's a backbone.
You know, this could be like, hey, so this is wood, built by wood, episode over.
Yeah.
So now I'm gonna, I'm gonna challenge you.
Yeah.
There's a lot of people saying that we can't do the shift to wood because we then need to deforest nearly all of the world, and we have a, everybody knows, hopefully who watches this program, knows there is a biodiversity crisis. And so we need to very quickly tell people there is, and maybe we can show it in a clip here. You have wild forest, unregulated wild forest with a lot of dead trees, a lot of dead wood, a lot of decompositions, not drained. And now we can see a classic production forest.
Urban mining, not urban, but a mining of
wood.
Of wood.
Yeah, and that is what people actually, most people know that from very, very straight trees in nearly straight lines, or it looks like a forest of beams, right? You're looking at me as I'm a total idiot.
No, but you're talking about a production forest.
Yeah, I'm trying to explain to our viewers what the difference is.
Yeah.
You're supposed to be my buddy in this.
Yeah, I'm trying to follow you, Anders.
Okay. Explain very quickly, why should we do the shift to building out of wood if we also have a biodiversity crisis?
Yes.
Yeah. Please fix that.
Yes, I'll fix what you started.
Yeah. Thank you.
So, yeah, you can be in the shot.
Okay, I'll be in the shot.
So, what Anders is explaining or trying to explain is, of course, that we have a biodiversity crisis. But when we shift or talking about building buildings out of wood, the question is, where does the wood come from? And one of the main issues is if we can actually use waste wood and create new building materials out of waste wood, so we don't even have to harvest the trees.
Oh, can you do that with this?
That's absolutely possible, and all the interior in this building is waste wood. We weren't allowed to do it with the structural wood, but we would have loved to, and we tested it, and we can come back to that as well.
When we go to the construction,
yes,
we can do that.
Yes, but the interesting part is here that you have deforestation, and then you have manufacturing or production trees. And we actually have a picture here of how much forest we have in Europe, and it's quite green. Right?
It looks a lot greener than
we would think.
Denmark.
Denmark is not even there.
Yeah,
that's where we are.
That's right mostly rapsmarker.
Yeah,
which is actually I have no clue what rapsmarker is in English right now. What is raps? What is raps?
Rapeseed.
Okay, grapeseed.
Rape.
No. Okay, say it again.
Rapeseed.
What?
Rapeseed.
Rape seed.
Like in rape?
Yeah, like rape.
Like.
Oh shit! It's even more. So we're actually raping the earth. We're raping
the earth with rapeseed.
We are raping our motherland with rapeseed.
It's a counter-sustainable. They actually named it right for what it's doing to our Mother Earth.
This is so fucking mind-blowing.
It's fantastic. Maybe that's an episode.
So, move on. So, most of this looks like there's a lot of forest.
Yeah.
But we still have.
So in north of Europe
Yeah.
and also in Central Europe, we have a lot of forest, and we also have a lot of production forest.
Yeah.
And
Mostly production.
mostly production forest. And creating a circular production out of that is making sense. What we have to learn now is that instead of using concrete that is using a lot of CO2 to create, the same with steel, we need to find something that's capable of sequestering and storing carbon. And that is trees. They are fantastically good at doing that.
Yeah.
What we need to do is find solutions where we use the wood, the trees, for something that's long-lasting. And what's more long-lasting than buildings?
Exactly, and you have actually shown it in this here, right? This is a way of carbon storage that we used to before we fucked it all up, then we fuck it all up, and then we're unfucking it up.
We're trying to unfuck it.
Oh.
But in this journey where we are now in 2023, looking towards 2050,
Yeah.
when we do these life cycle assessment that we've been talking about before,
The LC.
the LCA,
Yeah.
the wood is calculated as a carbon storage the
Yeah.
day that we build the building.
Yeah.
So when we're building these 20 stories and 15,000 square meters of building, we are storing so much carbon. There's 4,000 cubic meters of wood in this building. 1,000 of them is actually waste wood. So 3/4 of the building is new wood. But this wood is carbon storaging, and that means that we only have a CO2 emissions of 1.5 kilos for the whole building per square meter.
That sounds depressingly low.
It is very low, and that's where we want to go. So reaching 70% reduction, and the Paris Agreement is 2.5 kilos a square meter. So we're even lower than our target.
It's a good thing.
It's a very good
Oh,
thing.
I thought it was depressingly low.
No, it's depressingly
Shit,
good.
okay.
It's happily good.
I zoned out for a minute, sorry.
The problem is that then when we do our life cycle assessments,
Yeah.
we calculate the building over 50 years. So in this calculation, even though it's theoretically,
Who came up with that ridiculous?
we'll come back to that.
Okay.
Science. After 50 years, we have to burn the building theoretically. So all this wood releases the CO2 to the atmosphere.
Yeah.
And in that second we do that, we emit, in theory, as much carbon as some of the other building materials almost. And that's the problem. But in reality, they really are.
And you have that diagram.
And we've talked about cascading.
Yeah, cascading. In another episode we talked about. We're going to talk about cascading in another episode.
So just to explain what biomass cascading or cascading can do in this case.
Yeah.
So we've calculated a building through life cycle analysis, and we look at a building's material from when it's born as a building material, and then for 50 years.
Yeah.
But in reality,
because science says 50 years is the time a building is standing.
yes, so all materials is calculated in 50 years.
Okay.
But the fact of the matter is that beautiful structures like this last hopefully way longer than that. But in theory, we burn the building down in 50 years and it releases all its CO2 to the atmosphere.
Okay.
But what really happens is that it goes from being forest, production forest, to round wood, to solid wood, which is what we use for the facades and for the slabs.
Yeah.
After that, it can be particle-based products.
After 100 years, you can.
After the building is done, we can cut the massive timber up as smaller pieces of wood, and then after that, we can shred it, and it can become insulation or particle boards.
Yeah.
And after that, it can be recycled as fiber products, as toilet paper or paper and stuff like that. And then after that, it could be incinerated. But this is a way longer lifespan for wood as a kind of a cascading product.
And so what you're saying is that the cascading of products has not yet been calculated into the building industry.
We're not allowed to calculate in that our beams has an afterlife.
Okay, so that's why it's a big problem, because that makes right now the calculation of an LCA of a concrete structure or a steel structure and a wood structure is nearly on the same LCA because we have this short calculation, LCA calculation on woods.
And you can exactly, and you can wonder who came up with that idea. Maybe one of the industries that needs wood not to look too good.
Concrete.
So bless you.
Yes.
So bless you. It's really getting.
Yeah,
it's not getting to both. It's also getting to me. Maybe I get the same.
It's because we got sustainability.
Yeah. It's a good. It's a vitamin. Yeah. It's a good bridge.
Let's go talk about.
But I had one point to say with that, and I think the important thing is that the wood is a carbon positive. We call it a carbon bank.
Yeah.
Some call it a carbon sink. It has many names, but that's the fact in the matter that it contains and it sucks carbon in and sequesters it into the wood. Yeah. And when we build with it, we have a carbon storage.
Yeah. And so that is the last part here from 2020 to 2015. We need to enter this carbon storage in building and the recoming of forest.
Yes.
For building production forest.
And the most important point is that the problem we have is now. So every time we build something where we use energy, we use energy that usually is not renewable for concrete, steel, and many of all of these materials, and so we get more carbon in the atmosphere. With woods, with a tree and wood, it's the other way around. We're putting it into the material, taking it out of the atmosphere, and so the impact now is positive.
Yeah.
Here we are.
And here we are,
Fantastic. Right?
Anders.
It's beautiful.
You fucking did it.
Yes.
You built something out of wood.
It's very nice. So now we are up 4th floor, and the wood beams, the wood floor, the cores.
This is the actual wood bund.
This is massive wood.
So what is happening here, Anders? Can we go here?
So the thing is that when they crane these pieces in, then the assembly of these cross braces, which stabilizes the building for shear, like wind load and so on from the side, they're then lifted in and they're super heavy, right? And so mounted on these kind of steel brackets. And then they have these steel screws that are put in to stabilize it.
So I actually thought that because you were talking about that it was like here, right? You had the beam here, the cross beam here, and then you put the floor on top, right?
Yeah.
So I was actually thinking, like, from concrete slabs, that it was like one big pre-built element. Yeah.
But the thing is that when you build with wood, you have the ability, because it's, of course it's heavy, but it's not as heavy as steel and concrete. So you can transport more pieces at a time.
Yeah.
And you don't want to move air. So there's
it's like IKEA. So this is really, really big time IKEA.
It's a very big IKEA system.
But it looks so nice. Look
and smell it.
Look.
Smell it. Yeah, it's so nice.
Oh,
it's really
it's serious. This is, of course, we are playing to the camera, but actually, because I know a fucking lot about building material, right?
You know everything.
The thing is, when you see this quality, when you see this this way of you know, I may be over exaggerating, but I can already feel this is a fantastic building to be in. Look, I'm a tree hugger.
And you know what is interesting? And we're going to show this in a diagram. But when you look at how much wood that's harvested today, production wood, forest, and so on, only 1%, actually 1% of all the wood that we harvest is used for building.
Because it's used for this. it's getting used for this?
No, it's not even used for that. It's used for paper, packaging, all other kinds of stuff that has the shortest lifespan ever, which means it makes it a problem that we harvest forest.
Yeah.
But if we put it into the buildings and they are there for many, many years, then it makes sense. And the interesting part is, if you would build everything in the world out of wood, then it would only be half of the amount of forest we have today used for that we harvest.
So the thing, what could kick this into another gear is that if we shift to circular packaging, if we shift to all kind of, a paperless or some kind of reuse of paper all the time, then we could actually, with the release of that amount of biomass, we could build these buildings, right?
Exactly.
Yeah. Look, we have a drone. Look.
But the drone.
So this drone is operated by Casper. He's somewhere down here. This is a drone. If you don't know, if you haven't been living for the past 5 years in the modern society, this is a drone.
Oh, that's he's close.
And fun fact, Anders, I was flying drone last week, and first I flew a drone into a tree, 10 meters in height. Took me an hour to get it out, and then less than an hour after, I flew my drone into a lake. So this is very impressive work.
So that's why we have a different drone pilot. New drone pilot. That's nice.
Let's talk about the ratio of wood in terms of concrete, right?
Yeah.
We have these concrete. This is like the heist.
We have the concrete course, and the concrete course has all the fire stairs, the fire escape, all the elevators.
Yeah.
And because we have 2 cores here, because we're building such a high building, so you need to have more than one escape route when you come up. So there is fire elevators that are specific for if there is a fire in the building, you can get up and down. But so we have the concrete, and the interesting part here was actually that we could have made this out of wood.
The core could have been wood.
Yes.
But due to regulation or?
No, actually, I'm sad to say, but due to the fact that the walls would have been way thicker and taken more space up.
Okay, so these would have been
more thicker, and they would have been
how much more? So if you have this is a wall, right?
They would have been, I think, between 65 and 85 centimeters. So it would be really massive walls. And
okay, sorry, but it would have been likewise to this, right? Or even more.
Okay. Even more. So the problem with that was, of course, more material, but it would have been way more sustainable. And it was actually, we can see only the cores are around 17 to 18% CO2 emissions for the whole project. So we know
18, like 1/8.
Yeah, 1/8. So we know who's the, this disaster maker in just using energy and emitting CO2, and that's a super big problem. But we know where it is, and we should have done something different. But we tried it with this new type of concrete.
Yeah.
And
so this is actually we're gonna come back to another thing in another program about concrete. So what is this, Anders? This is a mock-up of the exterior on the wood.
Yes. So here we have a quite important piece, because this is the facades of the building.
Okay.
And the interesting part here is that it's all light material, so it's a light facade.
Yeah.
And when we say it's a light facade, then it's the opposite of the heavy, which is concrete and
usually is the opposite of light is
stuff.
Usually heavy. I'm just saying.
Getting us started here. And usually the whole structure in these wood elements is steel. So when you have these.
Sorry, I was having a discussion with one of the builders who's actually building this.
Yes, it's not
beautiful thing for you.
It's them. They're the builders.
But
But what I was trying to explain here is that these studs and structures inside this element is also wood, and normally it's steel.
Yeah.
You don't see it in these elements, but everything's steel.
Yeah.
So here we're saving a lot of CO2.
Yeah.
It's actually just the fact that we are exchanging the structure inside with from steel to wood. We save 50% CO2.
Yeah. 50?
50%.
On the whole building?
Yes. No. For the facade.
Okay,
element.
for the facade element. Yeah. And what is it? But this is not wood, right? The
No.
isolation is not wood.
So the fire legislation is super tough.
Yeah.
Actually, things are not allowed to burn at all.
yeah.
So of course this can burn, and that's why we need to cover it with, some gypsum boards on the inside, which
Yeah.
is not bad.
Yeah.
And then we have these cement bound plates on the outside.
And this, we're not that happy about that.
It's something that we could. It's the best thing we could find,
Yeah.
but it's covering 5,000 square meters of the building, and there is cement in them.
Yeah.
So it would have been fantastic to have an alternative.
So it's a composition material.
Yeah, and
Okay.
we don't like that too much.
But I think we need to talk about what I think is important in that thing is that because you're building this, you're doing so many groundbreaking things, right?
Yeah.
You're building so much new material, so many CO2 reductions that I actually want to hug you again, but I've been hugging you twice, so it's a little too much. I think one of the crucial things we need to talk about is when you build these kind of buildings, you will make compromises.
Absolutely.
So when do you decide to do a compromise, and when do you, are you going straight? One thing is regulation, right? Another thing is, are you sitting with your team and saying, okay, we need to focus on the most CO2 reduction and the method for the building method that will somehow show the way to build in the future, and thereby bringing down the CO2. Is that how do you?
We're a big team doing these projects,
Yeah.
and there's all the elements in it. So there's the concept, the idea, and the architecture.
Yeah.
Then there's the engineers calculating what is possible and how to do this.
Yeah.
And then we of course also have the builder and the contractor, how to put it together, and then we have the client.
Yeah.
And so we sit around the table, and everyone has what is important for them.
Yeah.
We have a common goal to do it as CO2, make as big CO2 reductions as possible.
Yeah.
But if there's some areas where we need to say, okay, we have to let go of that one.
Yeah.
What can we then do?
Yeah.
And the concrete in our course is one of them.
Yeah.
So it could have been wood,
Yeah.
but it's not.
Yeah.
So what do we do from there? And we're going to talk about how far we could go on the concrete, and we've done that,
Yeah.
absolutely, with a new type of concrete. But with these, also these cement boards,
Yeah.
we've taken the best product possible. But that's not where we made our innovation. It
No.
could have been.
But what we're going to do now is let's go downstairs
Yes.
and look at how the wood structure has been. How the fiber is being laid in the wood structure. What is up and down. Why is this this way and the other way?
Yeah.
So let's go down in the
let's
elevator.
do that.
I know it. I know it. I need to stop.
You look super cute.
But I need to stop hugging.
Very nice.
I need to stop hugging the building.
Stop hugging the building.
Okay.
Come
This
over.
is the beams. This is the beams that hold each floor, right?
Yeah.
Let's talk about the structure. What is this built up? How is it built up?
So all the columns, they need kind of their main job is to take all the weight and the load of the building vertically.
From floor to floor, right?
Yes.
So this
all
one,
the weight, everything that's piled up. Now we are on the ground floor, and we're going to have 20 floors all together. So there's 90 floors on top.
This is built of wood that is. How's the structure of it? Is it the cross-laminated thing, or is it?
No, this is actually a kind of a classical old glue lamp structure. So it does have glue in it.
Yeah.
And every piece, and you can actually see here that they're quite wide. I mean, it's quite big pieces that are laminated together.
And how? So I can see how long it is.
Yes. And they of course have an overlap so that they stabilizes themselves when they're kind of like brickwork almost, right? So they have different lengths, so you can use different pieces as well to do that. But the thing here is that they're all going in the same direction because a piece of wood is way stronger in kind of on the long side, taking pressure, where it bends out, but where it's the other way around, it bends down. So that's why they're in that direction here.
But I have a question in terms of sustainability. The amount of glue and chemistry in this is nothing compared to other kind of materials, or how is it?
It's of course we've been looking into how much chemistry there is in this glue, and from the 70s back then we didn't care about what was in it.
No.
Now we have a totally different control of what is in it. But it is an element that we would have loved to do something different, and it is actually possible to do something different. You can have small, you can say wood screws, or you can actually have nails in it, so you nail them together.
Like really old kind of buildings technique.
Where you basically shoot them together, and then you have steel pieces.
Okay.
And that's of course interesting because one thing is the sustainability part on CO2, but there's also the fact of off-gassing VOC, volatile organic compounds that are part of that equation. And so here it's optimized as much as possible, but there is glue in these.
But this is pure wood. Besides the glue, it's not impregnated. It's not salt impregnated or anything.
No. And actually, I just wanted to show you something. It's just more visual.
Yeah.
But there's a small mock-up here that kind of exemplifies it. So this is something that the guys here has just made to hold something. But the point is the same. And the pieces that are in our beams are really big pieces. So when you have reference to your kitchen tabletop, where it's smaller pieces, and laminated, the more glue there is in smaller pieces, the bigger the problem is. Here we have quite massive pieces of wood that are laminated together.
So this is comparable with. So this is actually. Oh shit! You took it like you took it much nicer than I did. So this is actually the same. So this is the.
So you can. It's just to exemplify it, and of course this is something just made here as a bracket or a piece to hold something in building it. But the system is the same. So it's the same direction of the pieces of wood and then put together. And this one is actually not screwed. This is not. This is not screwed. It's not screwed.
Yeah, you didn't screw. I only hogged wood.
You don't screw it. Okay, but
and I need to say something. We need to again emphasize that building with this wood, building with this minimum amount of concrete core, 18% of a usual building made of concrete. And what is the company called that makes it?
KLH, which is an Austrian wood manufacturer of CLT and glue lamp.
KLH.
And we're really happy with this work.
So KLH, either it's an old techno band from the 80s or it's a wood structuring building. We love you guys and we think this is the fucking future. Let's look at the floors, Anders. Because this is it me or is it another way? The floors is constructed differently, right?
Yeah. And of course because it has a different job in the building. Yeah. So it needs to span between the beams. And it has to horizontally stabilize the building, and of course be something that you can walk on that doesn't move.
So you don't take the beam. How's it built? You don't take you don't take a beam and put it down here. Do you have a visual of how?
Let's go over here.
All right.
Here, there it is. So this is a really nice spot in the building.
Yeah.
So there's this mezzanine put in. And then there's going to be, the reason why there's a hole here is because there's a staircase going up.
Yeah.
So we're going to be able to come up. But what we can also see is that instead of having the linear wood pieces as in the
from the columns, right?
Yes.
So the columns are built like this.
Yeah, and here we have a cross-laminated timber structure.
Okay.
And which means that we have them going across.
Okay.
Quite simple. And that's because we need this piece of the building to be able to take forces more horizontal and not just in one spot. So it can't bend down. It's not allowed to take loads in the middle the same as our columns can do, but it can span 6 meters. So
6 meters, could it span more, or is it regulated to 6 meters?
it's not regulated to 6 meters, but there is of course a maximum, because then the thickness of the slab gets bigger and bigger. So here it's 200. I think the average is 200 millimeters. That's between 200 and 240, I think.
Yeah.
But the longer the span gets without columns, the thicker it gets, and at a point there's too much weight in it, and it can't hold it anymore. So but the interesting part is that if you have a column and then 6 meter and a column again, then actually you would be able to just manufacture as long a piece as you want.
Oh.
So if transportation wasn't a problem, you could actually make
100 meters.
Super long. Yeah.
So like I was actually thinking of this. They say you can see, maybe the camera can pick it up, but you can see this is the end of the slab here and the end of the slab here.
So it's
and
three.
And then the element is built out there, right?
So it's three. You can say the building, the wood building is made out of a grid of 3 by 6 meters.
Ah, okay.
So you can see that there is, and that then creates the facades and the columns. And here it's a curved facade here, but it's easier to see on the straight facade. So we have this grid of these 3 by 6 meters, and you can see the slabs coming out like tick tick tick.
So basically the same thing as with the building, where you have concrete element that has a certain dimension, and you build the whole thing up. But you just replace that with wood.
Exactly.
Why don't everybody do this, Anders? Why don't everybody build with this? Is this more expensive? Is this much more expensive, or
today it is somehow more expensive? But the question is, where in the value chain is it more expensive? Is it when you buy the wood piece, or is it when you assemble it, or is it that you get less when you lease it out? And it's so new that we're learning all of these parts of building with wood, and it is a new and a first time to do it. So we're also seeing that some things are going quicker than expected, and there are some things that are more difficult. But for sure, this is the future.
But just we need to, on this show, we need to talk about, okay, nice, great. Everybody who's watching wants to build like this, but they go back and say, oh fuck, it costs 50% more. Is it that, or this way of building is like 20% more, 10% more?
I think the expected more price on this has been set on structure 10 to 20%.
So only 10 to 20%.
Yeah, it's not expected to be more than that. It is also a complex building, so building this even in steel or in concrete will also be more complex than just a simple straight up building. One thing I wanted to explain also with this structure, which I think is quite important. When we did the early stage of the design, now we talk about how the slabs are these 6 by 3 meters modules. But what we really wanted was actually to have beams going. So we had a column and a beam structure, and not a column and a slab structure.
Okay.
And the reason
I said okay, but I didn't understand it. Come over here and let's watch it here.
One of the things that we could have optimized here is the amount of steel.
Okay.
Because it is a hybrid building. We have to acknowledge we have some concrete, we have some steel, and we have a lot of wood. So there is 4,000 cubic meters of wood, so it's a lot. So that's good. But what we hoped we could have done when we started the design was to have beams in wood as well. So a column and a beam structure. So it's almost, I call it a grid structure.
Is that a beam? This
That's
one?
a beam.
So you wanted these beams to be replaced with wood?
Yes.
Okay.
And on top of them, you would put our CLT slab.
Yeah.
And that would have then been a bit lesser or smaller in dimension because it would be load bearing on the.
And why didn't you do that?
And that's the good question. Why didn't we do it? We didn't do it or weren't allowed to do it because then it would cost something in height of the building. So each slab is optimized always to have ventilation, acoustics, ceilings, and a kind of optimized room height. Here we have 6 meters high floor, so it's not a problem here.
Yeah.
But then the building would have ended up being
higher. How much higher?
1.5 floor higher.
And so that's actually a lot, right?
That's a lot.
So that's a lot.
So when you have 20 floors and it's 30 centimeters per slab, it adds up, right?
Yeah.
So the problem with that was who would pay for that? Would it be more or less sustainable to use more material and build higher versus the fact of getting steel in?
Yeah.
But for sure, it would have been the more sustainable solution to not have that much steel in the building.
I think what that, and we need to end the program now. But I think it's a very good way of ending it. It's like this needs to be collaborative, right?
Yeah.
It needs to be a collaborative between the developers, architects, the providers of the material, and really, really important, regulators.
Yeah.
You know, the municipality. I fucking can't.
Municipality.
Municipality needs to wake up, because the guys and girls who sit in these offices and makes decision about regulation are actually the gatekeepers for this, for acceleration of this.
And government.
Exactly. So listen out there. If you work in municipality, then you are responsible for this beauty. And let's end it there.